back to KhemWithKess, where today we'll be talking about multiplicity, also known as the N+1 rule, but for me, I just call it the nosy neighbor rule. So for all of these problems, I labeled down 3 where I've already gone over and discussed how many total carbons are in the molecule and how many H-NMR signals will show up in the molecule. For each one of the letters, after you have completed symmetry, you'll label each one of the carbons with letters. I like using letters for them because later on when we do C-NMR, we'll be using numbers. Then to determine the splitting pattern, that's when we're going to incorporate the nosy neighbor rule. As you can see, right here, straight down the line, I added the +1. That is a part of the rule. It's a foundational part of the rule. But the N is what you're figuring out. So since we're solving for N is all about our nosy neighbor. So let's assume that we go into A's house. So if we go into A's house, it is directly connected to B. So what you're supposed to be reading is how many hydrogens are on B. So my nosy neighbor theory goes on, if I go inside someone's house like A, what I'm going to do is ask them about their neighbors, always. I want to see how many hydrogens are surrounding them. So that's the idea. So again, for A is connected to B, and B only has 1 hydrogen on it. Then because we do the +1, that's how we end up with 2. Let's try another one. For B is next door to both of the A's. Even though there's symmetry there, we have to count each one of those hydrogens separately, and it's also next door to B. So when we do these numbers, we will see that on the A's, we have 3 hydrogens each, so we add those, and then on the letter C, we have 2. So these are a lot of numbers we have to count. So just be careful. 3 plus 3 is 6, plus 2 is 8, plus 1 is 9. Now you'll see that on my splitting patterns chart, I stopped at 8. So normally, back when even I was in school, after you get to 7, 8, and 9, they would just normally call this a multiplet. It's just pretty much too large to really count. And as you can see, the portions of how I drew these nice and neatly, when you start seeing those patterns, they'll start to smush together where you can't even read actually that you have 8 peaks or 9 peaks, but you'll definitely be able to see normally up to 6 clearly. So when we get to letter C, same idea. C is next to B and D, so we're counting the hydrogens on B and D. B only has 1 hydrogen, D has 2 hydrogens, plus 1 would now be 4 and would be labeled as a quartet. And again, with the splitting patterns, I don't think I mentioned it, but right here is the splitting patterns of what you expect to see. So if number 1 is a singlet, then I'm going to see a single peak. If 2 is a doublet, I'm going to see a double peak. 3 peaks, and 4 peaks, and so on. So that's what we're talking about, is the splitting pattern. How do we get that? We get that through the N+1 rule. Going back to D, D is now connected to C and E. C has a total of 2 carbons. E has a total of 3 carbons. 2 plus 3 is 5, plus 1 is 6. The hardest thing to do with these problems is make sure you use all your fingers and toes to count, in all honesty. Besides that, you're good to go. E is only next to D, so therefore D only has 2. So 2 plus 1 is 3. So there you go. You're done with number 1. Let's move on to number 2. Number 2 has no symmetry, so all we have to do is clearly find the rules for it. So the multiplicity. So for A is next to a carbon that has no hydrogens on it. Because this has no hydrogens, that's perfectly fine. You still have to account for it. A has no neighbors, so that means it will be 0 plus 1 is equal to 1. So A on the H-NMR spectrum would show up as a singlet. When we're dealing with letter B, B is next to the carbon that has no hydrogens, and it's also next to C. So for that one, since B is next to C, C has 3 hydrogens on it, plus 1 equals 4, making it a quartet. And then for C, C is only next door to B. B has a total of 2 hydrogens on there, plus 1 makes it 3 and reads as a triplet. See, it's not that bad if you use my nosy neighbor rule. Now for number 3, I didn't do any of the symmetry for it just because I wanted to go through it naturally with you. So for this one, you'll see that the line of symmetry goes straight through the benzene ring, which we talked about earlier, and why there's symmetry there. Then we have to make sure that we see that carbon has all its 4 bonds. Like for instance, this carbonyl right here has a total of 3 bonds, which lets me know there is a hydrogen that's located there that I could see. And that hydrogen by itself, remember when we talked about the H-NMR spectrum, aldehydes and carboxylic acids will show up. So I'm going to label this one lonely hydrogen by itself as A. Now, because it is not a carbon, for A, we are not able to use the +1 rule. So A is only going to just read as a singlet, and the same thing would happen for a carboxylic acid. Now let's go through and label the rest of them. So remember, we're only labeling carbons that have hydrogens on them. This one does not, this one does not, and this one does not. So the next letter would be here, which both of these would be B, C, D, and E. I guess I kind of gave it away since I labeled the letters for you right there. I didn't mean to, but let's continue and carry on and figure out the multiplicity. Now for B, you'll see that B is next to the carbon that has 0, and then it's also next to C that has 1. So that's going to be 1 plus 1 is equal to 2 for a doublet. Again, we look at C. C is connected to B that has 1, and next door to it has 0. So that's going to now be 1 plus 1, 2 again, doublet. D is next to a carbon that has 0 and an oxygen. We can't do anything with that oxygen, so D is pretty much by itself. So that's going to be 0 plus 1 equals 1. So that's your singlet. And for E, same idea. E has no neighbors because there's not a carbon that has hydrogens on them. So therefore, that is going to be 0 plus 1 is equal to 1. Let me know what you think, and let's go over what it looks like to bring all of these concepts together with the spectrum that normally bothers the heck out of y'all. See you soon.